Welcome to a new test and teardown video. Today I'm going to see if I can get Velleman instruments up and running on my computer. Look at that. I got a 2-channel USB PC oscilloscope. 2 times 60 megahertz. Really? At the same time? Yeah, you need some software, and there is of course a CD installed. I think this is quite old, and I don't have a CD drive anymore, so I spent a lot of time on their websites trying to get the right software, and finally I think I got some software. We will see what happens. So I will start the video with the PCSU1000. That is the digital storage oscilloscope. So let's unpack it and let's see if the software works. It's quite amazing. Somebody bought this quite a lot of years ago and put everything in a box. So I got everything, including a very nice manual. Of course, you need a magnifying glass or something like that to read this, or very good glasses. They talk about the PC software is for Windows 2000 Vista or NT or something like that. Yeah, here it says. So you can probably imagine this could be up to like 20 years old or something like that, right? Oh yeah, the software here is called version 3, and I was able to find 4.7. No, 407 is what I found today. So that is what we're going to talk about if this works. Just bear over me because I don't know anything about this. This is the first time I start this software, and it seems to be pretty straightforward. All I have to do is say yes, okay, we're calibrating. It looks like it is connecting to my unit here, and it's doing a little bit of light and blink and such, and then okay. So now what? So I've been playing with this software install and getting everything up and running. I think a few hours now, to be honest. And I think I am quite happy about it now. I did also unpack the function generator. The function generator got 2 different outputs. And the 2 outputs, they are the same, by the way. And they can be programmed to do almost anything, really. And you got a sync output, and at the moment I've just connected the sync output and the function output to the 2 input channels of the PC scope, and I got this up and running here. I have set down the resolution of this screen to 800 by 600. Because this software is definitely designed for ultra low resolutions. And you can control everything from here, just like a normal scope. You just click with your mouse, and then you can do all the different time-based stuff like that. And there is quite a fast response. There's a reason why I'm using a cell phone here to record the screen like that. But I will plan to record it somehow else. I think this is a little bit annoying just right now, but I wanted to show you the lag and how it really responds. So here we go. I just clicked on function generator, and then it will automatically pop up. Here is the function generator interface, and I selected sweep and set it for 20 seconds. And then you can just minimize that, and you don't need that. It is because I want to show you what is going on here. I think the updates, can you see? Now it runs, oops, see? And again. So there is a funny little delay in the updates now and then. I don't know how visible that is. See? We got again and again, like every 2, 3, 4 seconds, there's like a quarter of a second where it just stops and think about something. And it's not like my computer is overloaded. I mean, this is the fastest notebook you can buy for money, and this program is using 0.2% of the available CPU resource, and I got everything 333. So definitely this program is not using a lot of CPU load, but it's also a 32-bit program, by the way. Yeah, so other than that, the program here is very, very straightforward. And we got tons of cool features. Yeah, of course, there's a built-in spectrum analyzer, transient recorder, circuit analyzer. You can do sweeps of amplifiers and all that kind of stuff, especially when you got both the signal generator and the function generator, the scope together with that. Then you can sweep stuff. It's just really, really amazing, I must say. Now you can imagine I run the program in a more modern kind of screen resolution. This is the screen resolution that this monitor is designed for. So it's 2500 or something like that, right? Yeah, 2560 by 1440. So that makes this program tiny, tiny. And then there is this little feature here called big screen. So what kind of big screen is that? Let's hit the big screen. And here you go. This is your big screen. And then you have your control panel for your scope or your function generator. You can pull it out like this, and then you can do everything at the same time. So that is quite nice, except for this little annoying lacking stop thing. Other than that, I think it is really nice and sexy. Okay, they are not that big or anything. You could probably hide them under the screen, and you can maybe make a nice little setup. That's probably possible. Oh yeah, they claim that this unit can do 60 megahertz and giga sample and all that kind of stuff, and maybe that is right. If you look here, we got the giga sample modes, and if you go to giga sample modes, it is only for signals that repeats themselves, and that means it's gonna time skew and then resample, and this way gather a higher resolution. But in real life, it can only do 0.1 microsecond per division. And by the way, if I even try to activate these modes, yeah, the program and the hardware crashes. So it is not working, at least not for me, really. So if we look a little bit closer on the scope, here is the test pad for your probe on the back. Really? And then of course the USB. So there's this little funny plastic piece there, and that is for this foot. So if you push this up like that, then it's not gonna fall so easy. I kind of like the stand-up design. You know, it's not gonna occupy so much space on your desktop. You could hide it. Yeah. Let's see what is inside this fantastic PC scope, shouldn't we? It's probably just those screws, right? The inside of the case is coated, but maybe it is connected using these. As you can see, it's metallized. Here at the bottom, we got rusty iron, and that is due to this piece of rusted metal here at the bottom. And of course they wanted to create a little bit of gross, a little bit of weight down the end. That is not so nice. I think it's more or less falling apart here, right? And do mind when you're playing around with stuff like this to be anti-static safe. I am completely safe here at my workbench, but you shouldn't open stuff like this and play around with this if you're not carefully protected against static discharge. Wow! Look at that! A Xilinx Spartan. So that is one of them hefty FPGAs. Wow, nice. And a PIC 16 F630. Wow, so that's for bootloading or what? And then it's loading the software when it connects. Ah, that is brilliant. So it's just an FTDI. Yeah. Just an FTDI. The USB serial interface. This can do quite fast, by the way. Megabit baud rates using the USB. So serial, and then this is some simple bootloader software that connects to the PC, and then upload everything, and then you're good to go at super duper speed. And all those are read relays. That's doing different ranges and gains and all the nice stuff. And that will be our 280 converters. How about we have a little look here? Is it possible to get this info? Oh yes, let's see if we can go into macro mode here. Come on, man. So that is the 80 converters in super duper bad shitty focus. Why is it always like that? Come on, man. Why don't you? I'm probably gonna take a nice picture here and put in the this is just the worst day of my life, man. Come on. Thank you. No. So here's the ADC, and the ADC is from National, as you can see, and it's doing maximum of 60 mega samples per second. But if we look here at the front, giga samples, 2 times 60 megahertz. And that is of course because they're using the FPGA to time skew samples, and then signals need to be repeated, and then it will make up a really nice and fast curve. But it's using a much slower 80 converter to do that. And by the way, I really don't think that any of that will work so much, and I'll probably show you why. And that is because when I go in the faster, like the last 3 or 4 time-based settings, then I do see quite a lot of jitter on the readout or on the display, right? So that just proves this function that is absolutely not going to work when there is this much jitter. But other than that, I think it's quite nice. We see it's from 2005. And I also see, I think it was 2005 on some of the chips. So it's not only the design, but this one is from 2005. And I did, of course, already yell and scream about this in previous videos, but I will probably do that a little bit more in this one as well. And that is when you buy an oscilloscope or a product like this, that is, I mean, completely tied up to a Windows PC and the operating system, the software, everything like that, right? You can't even take this software and use it in a newer operating system, because then you need to update it and all that kind of stuff. So you already, when you buy stuff that is PC based, you just know you're not going to have it for a very long time, because the next few updates, the company that made the software, they're gonna discontinue drivers and stuff like that, and then you have a product that is not working anymore. If you buy, a regular scope like this, that is a standalone scope, as long as it's not blowing up, right, it will still continue to work. So that is my little concern about having stuff that is PC based. But yeah. Let's try and play a little bit with the signal generator, or they call it the function generator. It's actually quite nice, especially when you look at the output here. I tried to measure its harmonic distortion, and yes, I did calibrate it correctly, but it is 0.02%. Very, very good. It's super nice and clean. How about we try and crank up the frequency and see if it's still the same. So I just tried to measure THD at a much higher frequency. So this is 20 kilohertz, and now the distortion is, of course, much less. And that is because now the filters, the output filters, starts to kick in, and then they help smooth the output. So that means we could probably also try and test THD at a much lower frequency. Then we'll probably see the 8-bit resolution a little bit more. And yes, I was right. This is again another THD measurement. Well, now the number is 0.06, and this is at 20 hertz. I think I found out what was causing my jitter and my problems when I was running in the faster sweep of the scope. I was, of course, using this function generator as my signal source for the scope. I don't know if you can see what's going on here. Can you see? The curve is moving left and right, like it's a little bit unstable. Really, really weird, huh? And this is not my scope, I'm telling you. This is absolutely not normal to see, because it's completely filtered and fixed, and I don't know what the heck they're doing. This is not what I see normally. So yes, there is some funky jitter going on in this function generator. I want to open it and have a look. Don't you think it's a little bit funny? The function generator uses a 9-volt external power supply, but the scope doesn't. I think that is a little bit... Can I do this without getting hurt? No, I cannot. Let's look a little bit inside the function generator. It looks very much like the same kind of idea. Of course, we can see it's the same company. This one is from 2008, so they made the scope first. And of course they figured, hey, let's make a really nice function generator too. That is definitely what we can sell. So they're using the same Xilinx Spartan FPGA, and that is a very good choice. And then they're using a PIC16 F627A for the bootloader, and there's a 10 megahertz crystal here. And the fun thing is, now we have an optical interface to the serial port. So this is just an RxTX serial port, quite slow speed with those optocouplers. And now they're using a different brand. See, the Scilabs So this one needs another driver, so they obviously figured that out. And that is why you have a DC supply, because you have an optical isolated communication port, right? And this is a good way to minimize hum loops or scope grounding loops. So definitely a smart idea. What else can we say? Yes, I wanted to show you. This is the DA converter. This one is called a TX DAC, and the type number is AD9748. And what do you know? It's of course an 8-bit, parallel, but super linear, super fast, 210 mega samples. Whoa, wow, they're really overdoing this a little bit. And then they have a limit of only 2 megahertz output. They could easily have made this a lot faster, and this baby here can definitely spit out a lot of they could have done this, I don't know, much faster. And there's another fun thing that you have probably already seen. Look at those resistors here. This is an R2R. So that is another DA converter they have made there, and then a little op amp. And I think the output from that op amp goes to some of the other op amps here, and that is our DC offset, because you can also offset the output. And of course you don't want to limit your, or to do this digitally. Of course you want another DAC that is doing the DC offset. That is definitely how it could have been done, right? And this is the TTL output. They're using an IC here and a single bit also from the FPGA. It's actually that one that goes to that IC there, and this is generating the TTL output. Yeah, we got 3 little regulators for the different voltages, fuse, reverse voltage protection, all is, quite nice for a 2-layer board. Oh, there was actually another little funny thing I would show you. It is of course not the most beautiful layout or anything like that. They just did this as fast as possible. Didn't think a lot about a lot of details, but look at that track here. First you go out and then you go in, and then why are you going in and out here? I mean, really? Maybe making like place for something, or reserving some place here, or not knowing what you want to do. Because in this area here, see, there's nothing we need to make room for. That is a little bit funny. Yeah, I always look at PCB layouts like that, because this is kind of what I do for a living. So it's always funny to see how smart people are when they are doing PCB layouts. There's another really bad thing about this PCB layout here. Yeah, of course it's only a 2-layer board, but all these areas here, why aren't everything stitched together? It's just not. Only one little, I mean, really? All those areas not stitched, all this not stitched. I always do proper ground stitching, so the 2 layers just merge together and form a completely closed ground plane, really. You can really do a lot better on a 2-layer board if you are smart. So, this is all I wanted to say and all I wanted to show you about these Velleman PC-scope and the PC Function Generator. I hope you had at least a little bit fun, and maybe you will think about it. Do you want a PC scope thingy, or do you want a standalone thing? There's definitely pros and cons no matter what you do. Thank you very much for watching, and bye bye.